if we have any tests or quizzes or anything like that. So there's going to be 2 equations today kind of for each one of these. All right, so a direct variation in the description will say something like y varies directly with x. And the equation looks like this, just y equals kx. And k is just going to represent a number that is called actually your constant of variation. So in that, k is the constant of variation. That's what they call that. So just as a little, like a couple examples. So like, let's say we had, I don't know, literally something like that, like y equals 5x or y equals negative 2x or something like that. It's just a number multiplied by x. There's nothing added or subtracted to the side. It can be positive or negative. And I do want to show you, because this will confuse people sometimes, most of the time if the k value is a fraction, right? I would probably, let's say I had y equals 2/3 x. I could write it like that. Another way you could technically write it, though, you could have 2x over 3. That would be the same. There's a couple problems that might do something like that, but that's still a direct variation. You've got a number attached to your x. The x in that case, notice it's in the top of the fraction. Like if I did 2/3 times x over 1, the x would get multiplied by the 2. So the variables in the top, that'll be important for what we'll get into in the inverse variations on the back here, how they're different. Okay, now I'm just going to show you this real quick. So if I took that general form, y equals k over x, or k times x, sorry, how could you solve that equation for k? Like how could I get k by itself on one side in that equation? Y divided by x, right? So if you just did this real quick, I would divide both sides by x. Every time your k value is y divided by x. And so these are the 2 formulas for your direct variation. The actual direct variation is the y equals k times x, but how you can find the k value is you can take y divided by x. So not so much in a graph, but if you have points or if you have a description, the y equals, or y over x equals k can help you a lot of the times. And I always remember if it's direct, you divide. Okay, now one other thing that I'm going to jot down before we look at these graphs here real quick. So because of the format of this, if you graphed, I just want you to think about it for a second. If you graphed like y equals 5x, or y equals negative 2x, or y equals 2/3 x, all 3 of those examples, if you graph them, what would the y-intercept be? Anybody know? It's the same for all 3. Where would you, like if you were graphing mx plus b, where would you start that graph? It would be 0. Okay, all of these graphs, this is weird, but they all go through the point 0, 0. And in each case, it's the y-intercept because you don't have anything added or subtracted to that. So anytime you have a direct variation, it's just a line. The k value is really just your slope, and they have to go through 0, 0. So I'm going to give you a couple questions like this. These are just graphs, right? And it just says for each of the functions, determine whether y varies directly with x. And then if so, find the constant of variation and write the equation. Okay, so if I have a graph that I'm asked if it's a direct variation, I can just look through here and immediately, if they don't go through 0, 0, like the one in the middle, this does not go through 0, 0. So automatically that's not a direct variation. These other 2 both are, because they do go through the origin. So if they go through the origin, these are both, this would be yes, this would be a direct variation. Now, what your k value is just the slope of the line. Can anybody tell me for that first picture, like can you tell what the slope is just looking at the graph? Dakota, what do you think? You're so close. 1/2, yes. Going up, rise over run, up 1 over 2. If you're not sure, just grab 2 points that go right through corner and just rise over run. We're going up 1 over 2. Now, if you have to write the equation, literally all you have to do is write y equals 1/2 x. That would be the equation of that line. Can anybody tell me the k value for this other graph? -3, definitely. All right, and then so if I want to write the direct variation, I would just write y equals -3 times x. Is anybody have a question? Okay, now if you don't have a graph, if you have a table, which is what we're going to look at here, to decide if it's a direct variation, remember what we just said at the top, that the k value should be y over x. So if you have actual points, which I have 3 sets of points for each one of these examples, all you got to do is check and see if you divide y by x, if it's the same for each of the points. So like here, and you don't have to write out a bunch of work, but like 4 divided by 2, that's 2. 8 divided by 4, that's 2. 36, I'm just taking the y coordinate divided by the x coordinate. 36 divided by 18 is 2. They all have to be the same. If one of them's different, then no. But yes, if these are all the same, then yes. And that is going to be your k value. So this would be y equals 2x would be the equation. So we're just checking these. So just check for each one. Like if I do this one, 9 divided by 27, what would that reduce to? Not 3. 1/3, right? All right. 10 over 30, same, right? 1/3. 20 over 60, same, 1/3. As long as they're all the same, which they are, that's your k value. So this one's direct, and I would just go, okay, y equals 1/3 x. Now, that's how I would typically write it. I would also take it, if you wanted to write it, like y equals x over 3. The k value there is 1/3, but there's 2 different ways you could write that, and that would be totally acceptable. Okay, let me try one more. All right, so 66, I'm just taking y coordinate divided by x, right? That's 6. 40 divided by 8, that's 5. Right there I would stop, because if they're different, then it's not a direct variation. So I don't keep going there. I don't find a k value, because it doesn't exist, because those 2 numbers were different. Does anybody have a question? Okay, now the third thing you might have to do is determine if it's a direct variation from just an equation. So the easiest thing I can tell you to do if this is your problem is get y alone and then decide. So like you might be able to tell pretty quick without doing a bunch of work. But in that first equation, I just have 4y equals 5x. So to get y alone, I would just divide both sides by 4 here real quick. So I could write that as 5x over 4, or like I like to pull that fraction to the side, this would be 5/4 x. Would you tell me yes or no, is that a direct variation? What do you think? Yeah, it for sure is, yes. The k value is the 5/4. Can you guys tell without even doing the problem if that second one is a direct variation? Like if I got y by itself here, I'm going to divide everybody by 3. So I get 3x plus 2. Is that going to be a direct variation? No. If you it literally just has to be number times x, nothing else involved. If you have adding or subtracting, that ruins the whole thing. So this is not going to be a direct variation. Or you can just write no, you don't have to do a bunch of work. Like I could tell before even doing that problem that I have this thing added to the side, so I knew it wasn't going to be, but anything added or subtracted ruins that. It has to be just a plain number times x. Okie dokie. Now, these are the types of problems you're going to be asked to do. So it says the ordered pair is from a direct variation. Find the constant of variation k, write the equation of variation, and then it's going to ask you, all these problems ask you like a secondary question to find some missing value. For a direct variation, just remember the k value is y divided by x. So if I have a point, I can find that super quick. So the k value here, my y coordinate is 15, my x coordinate is 5. Literally all I have to do is divide there. So this would end up being 3. So there's my k value. So if I have to write an equation, all we have to do, write y equals 3x. And then there's kind of 2 ways to do the second part. So they always give you like this secondary question. So this says find y when x is 6. Over here it's going to ask us to find x when y is -4. So first option, you can just use the equation, right? We just wrote this equation. I could do this and I could say find y when x is 6. So y would be 3 times 6, totally done. Y is going to be 18. Okay, now the other option, if you have a point, right? I have this 515, and this says find y when x was 6. So this would correspond to, okay, the point 6, and then I don't know what y is. The other way to do that, maybe you don't have to write the equation for the problem. If you don't have to write the equation, you could actually just make yourself a proportion, because any point on the direct variation has to have the same k value. So I could set up like 15 over 5, y over x has to be equal to, we don't know y, and then over the x coordinate they give us, which is 6. And we could just do cross multiply divide. So that's just another option for you if you want to use that instead. Okay, I'll give you the same answer. All right, now I had to, of course, involve one that has a fraction. So to find your k value, should just be the y coordinate. This is 1/3 divided by 3. Okay, we could do this on the calculator if you want to, of course. And I would just tell you to put parentheses around the 1/3. But I'm just going to show you this to the side here. 1/3 divided by 3 is the same thing as multiplying by the reciprocal. So 1/3 divided by 3 is the same as 1/3 times 1/3, which is 1/9. And to be honest with you, if I see a problem like that, I know what's going to happen. The denominator here and the denominator, or what's in the denominator, those just get multiplied together to create the solution for that. So k is going to be 1/9 for that problem. All right, now to write my lovely equation, all I do is y equals k, which is 1/9 times x. And for this guy, we want to find x when y is -4. So if you want to use the equation, we could do -4 equals 1/9 x, because we know the relationship there. I would just multiply both sides by 9 real quick to get that. So -36 would be equal to x. Your other option, like I said, if you have a point here, so this would be the point. I don't know x, but -4 is the y coordinate. So the other option there, you could do a little proportion. Just do that 1/3 over 3 has to be equal to -4 over x, and you could do it that way too. It's totally up to you, whichever is easier. Is anybody having a question? Okay. Now, this is probably going to be very new to you, so we're going to do an inverse variation on the back. These are a little different. So an inverse variation is going to be more what this unit is about, and that's going to deal with the fraction. So this is y equals k over x. So your variable is going to be in the bottom of a fraction here. So k is still that constant of variation. It's just going to be a number. We are not going to graph these today. We'll spend a couple days graphing these because the graphs look really weird. So we're not going to graph anything with this today, but I'm just going to show you a couple ways this might be written. So we could literally just have, I don't know, like y equals 6 over x as an example. I could have, it could be negative, like we could have -4 over x. That could be an example. We could have, let's say I had something like this, 5 over 2x. It's different from the direct because in this case, if you have an inverse, the variable x is going to be in the denominator. All right, so like my k value here is 6, my k value here is 4. This little example, my k value would be 5 over 2. So there's different ways that these can look, but for an inverse variation, what you're going to have is you're going to have the variable x, or might be a different letter, but it'll be in the denominator of that fraction. Okay, now if we took y equals k over x, and I said to you, hey, let's get k by itself, how would you do that for this equation? What would you do to get k by itself? With k over x, like how could I get k alone? How would I get the x away from it? What do you think? Yes, you're just going to multiply. All right, so the two little equations that go together here, k is x times y. And I know this is weird because if you look at the equation, the inverse variation is k over x, right? We're dividing something, but the way you would actually find the k value is to multiply. And the direct, you're multiplying, but the way you find the k value is you divide. So it's a little bit tricky, but these two formulas are going to be what you want to know for your inverse variation. What you do here to check if you have a table, this one I think can be a little bit faster. You're going to multiply. So k has to be x times y for all the points. So like if I do 2 times 15, 30. 4 times 7.5, I should grab my calculator, but I'm pretty sure that's 30. 10 times 3, 30. 15 times 2, 30. As long as they're all the same, they have to be the same, then that's going to be your k value. To write an equation here, you're just going to put that number over x. X will be in the bottom here. These are easy to check too. Like if you want to plug in your x value, like if I did that first point, 30 divided by 2, that's 15, so I know that's right. So these are easy to check if you want to plug them back in. They all have to be the same. If I do this one, I'm multiplying to check if it's an inverse variation. So this would be 20, this would be 32. I'm just going to stop right there. That's not an inverse variation because those two numbers are different. If any of them are different, then it's not. Oh my, you guys might have to help me. I don't have my calculator up here. What is 0.2 times 40? 8. And I know this is 8, this is 8, and this, so these are all 8. So as long as they're all 8, that's your k value. So this one would be yes, 8 would be the k value. Does anybody have any question about how to check that? If you have a table and it says, is this direct or inverse, just as a recommendation, I usually check inverse first because it's faster for me to multiply two numbers together than it is to divide and maybe reduce. But if you multiply the two numbers together for the x and y coordinate and they're the same, then those are going to be an inverse. If you divide y by x and they're the same, that's going to be a direct. Okay, so these are like the questions on the front, right? They're going to ask you a secondary question. This is a little faster, I think, just to find the k value, because all you have to do, multiply the x and y coordinate. That's all you're going to do. So the k value here, this will just be 2 times 5. K is going to be 10. So again, there's a couple ways you can do this one. Your general equation here would be 10 over x. And they always ask, like, find x when this is whatever, or find y when this is whatever. So they'll give you this. So we can just use the equation if we want to. So it says find y when x is -3. So I would do 10 over -3, and there's really nothing else to do there. I can't reduce that or anything. The other option, if you have this situation for an inverse variation, you're basically here being given the point -3, and then we don't know why. So the other option here, if you know the x and y coordinate of a point, both of them, your k value, 2 times 5, would have to be equal to -3 times y. So that's another way you could set that up if you don't want to write the equation out. If you have the equation, you can do it that way too. You should get the same answer. Okay, so then for this guy, again, if you have an inverse variation, you're just going to take x times y. So what do I get if I take 1/4 times 28? Anybody know it's a nice number? 7, for sure. All right, so this would be y equals 7 over x. Okay, so two options. First option for that secondary question says find x when y is 2/5. So in this case, if we want to do this, y is 2/5. So I would just sub in 2/5 for y, 7 over x. And that guy, I would just do like a quick little proportion. So we'd have 2x equals 35, and 35 over 2, which is 17.5 as a decimal. Now, the other option on that one, again, if you have a full set of coordinates, so like the 1/4 times 28, which is your k value, has to be equal to, what I have here, I don't have an x coordinate, but I do have a y coordinate. So this would have to be equal to whatever 2/5 times x is. You could solve it that way as well, whatever is faster for you. You don't have to full on write the equation. That can be another option. Does anybody have a question? Okay, now I'm going to do 2 at the bottom. We're going to have a little word problem that we're going to create an equation from. Okay, so your class volunteers to pick up trash at the local park. Now, it says the time it takes, so that would be t. I'm going to use t. the time it takes to pick up the trash, I'm just going to use T, varies inversely with the number of volunteers. So let me just use V for the volunteers. Okay, so I'm just going to set up an equation. So inverse variation is something equals some number over another variable. All right, the word varies, if you see that, is going to turn into an equal sign. Varies is going to turn into an equal sign for any of these problems. So I'm going to say my time varies. And then automatically, because the K value is never part of the description of the variation, so you have to remember to put a K value in. So just don't forget, just immediately after you write the equal sign, I would just put K. And then it says it varies inversely with the number of volunteers. So inversely is going to tell me we'll have a fraction, so I'm going to put that number of volunteers underneath. Okay, now they're going to give you just enough information to figure out the K value. And that's going to come right here. It takes 3 volunteers, 85 minutes. And I know there's more to that sentence, but those two numbers are going to help me find my K value. So I'm going to do that first. So it says it takes 3 volunteers. That would go in then for V. 85 minutes would go in for T for the time. So I would do 85 equals K over 3. And we would just multiply there. Can somebody tell me what 85 times 3 is? 255? Okay, now, a general equation for any situation we would have beyond this, I don't know why I just wrote a Y, the time should be 255 divided by the number of volunteers. Okay, so takes 3 volunteers 85 minutes to clear the trash. Then they're always going to ask you the secondary question. How long would it take 5 volunteers? So we're going to find the time here. Don't know. It's 255 divided by the number of volunteers, which we're going to change to 5. And so to answer that second part of that question, we're just going to do, I think that should be 51. Does that sound right? Okay. So 51 minutes. Whatever units the time was in, that's what our answer will be in. So they said 3 volunteers, 85 minutes. So if we got 5 volunteers, it would take 51 minutes. Does anybody have a question? Okay, let me try one more here. All right, this one says your distance from lightning, so I'm going to use D for distance, varies is going to be an equal sign. So I'm going to just write D equals, and as soon as you write the equal sign, just put a K after it so we don't forget. The K value will never be in the problem described. You have to find it. Varies directly with the time it takes you to hear the thunder. So let me just do T for time again. Okay, if you hear thunder 10 seconds after seeing lightning, you are 2 miles away from the lightning. All right, so for that part, you're 2 miles away. I don't know the K value, but it says it takes 10 seconds. So I'm using this to find the K value. Divide both sides by 10 there, and I'm just going to reduce that fraction. So it'd be 1/5 is my K value. So a general equation for this, the distance away that you are would be 1/5 multiplied by the time it takes you to hear it. So that would be just a general equation we could use for this situation. Then they always ask you the secondary question. How many seconds would it take for you to hear thunder if the lightning is 4 miles away? So for this question, just make sure you plug in for the right variable. D is for distance, so 4 miles away, 1/5 multiplied by the time. How long would it take? So I know I'm going to solve for T. What I would do there, just tell you real quick, if I'm multiplying by 1/5, I would multiply both sides by the reciprocal real quick, multiply by 5 to get that away from the T. So this should be 20. And that's your time. This is going to be in seconds. Because the time in the original information was also in seconds. Is anybody having a question?